Hello friends, good morning. I welcome you all to the session. So in the last class, we discussed about PYQs on axiomatic approach to probability. So in today's class, we'll continue our discussion on probability. So today we are going to discuss what? We are going to discuss about conditional probability. What? Conditional probability. So let us get started, friends. So before that, I'd like to inform you about our course. So we were doing about, discussing about probability. So before that, I'd like to inform you about our course that is starting on October 1st. That is, first one is Secure Below AIR Rank Assurance Program for IIT JAM Biotechnology, Feb 2025. Okay. So the USP of this program is it is a well-designed 6-month plan. It is a 6 months course. Okay. You will be having what? Interactive live and recorded classes. You can attend live classes also in case you are a working aspirant. If you cannot manage the time, you can even watch recorded sessions. Okay. And those who are full-time preparing, they can also watch recorded session if you have doubt with respect to anything, or if you want to revise, you can watch the recorded sessions any number of times. And the hallmark of Chandu biology classes is well-crafted PPTs. Okay, the PPTs will be very exam oriented and it will help you in revision and also revising the concepts. Okay, also what? Gaining clarity about the concepts. Okay, next we are having expert design study material. When it comes to study material, we are only providing the study material and doing the classes, going through the material is not enough. Apart from that, you need to test yourself. So we are having both sectional and full length test. So 13 chapter wise, what? 13 chapter wise sectional test. That is chapter wise test means it is sectional test. Then 10 mock test. That is full length test. And apart from that, like what we are doing, we will be having classes for mathematics also. Okay, mathematics with respect to IIT JAM, and also GATB. Next, individual attention is given to every student. You can contact Chandrasekhar sir, Dr. Chandrasekhar sir, or me with pertaining to the respective subjects. Okay, so sir will be what handholding you throughout your journey of your preparation until you secure a very good rank. Okay, and the fees for this course is very nominal. It is 22,000. Okay, it is almost 22,000. Next, coming to another course that we are starting. This course is starting from when? It is starting from 1st October. Remember, friends, it is starting from 1st October. Next course I want to talk about is this is also secure below AIR 100 in which exam? In GATB and CUET, that is Common University Entrance Test, that is for PG 2025. So this is a 8 months plan and the fees is 22,000. Other USPs remains the same. Other USP of the program remains the same. That is, you'll be getting well-crafted PPTs, okay, expert design, study material, and 13 chapter wise and 10 mock tests. Individual attention will be given to every student. So those you are aiming for GATB and CUET QET PG 2025, you can take up this course. This course is also having the fee of 22,000. That is 22K. Okay. And this is also starting from 1st October. Remember, friends, it is starting from 1st October. That is very much approaching. So please enroll to the course as soon as possible and get ahead with respect to your preparation. All right, friends, let us continue our discussion on probability. So in the initial classes, we discussed about basics of probability. We learned about the terminologies related to probability. We learned about terminologies like what is a trial, outcome, sample space, random experiment. When it comes to event, we learned about what is an event, what is a mutually exclusive event, what is an exhaustive event. Then we learned about partition of sample space. And later we learned about axiomatic approach to probability. In the axiomatic approach to probability, we learned about addition theorem and questions based on addition theorem. That is, PYQ is based on addition theorem. All right. So we have learned about basics of probability and also axiomatic approach to probability. I told questions are repeatedly coming from axiomatic approach to probability. Likewise, learning conditional probability is also very important. Okay, conditional probability. Okay, so today our topic of discussion is what? Our topic of discussion is conditional probability. So what is conditional probability? What are the properties of conditional probability? All those things we are going to learn today. Okay. So today our topic of discussion is conditional probability. Those who are watching the sessions for the first time, I want you to watch the strategy session, then watch the remaining session. That is basics of probability, then axiomatic approach to probability, and then come for conditional probability. Okay. So it will be very much clear for you. You will have a lot of clarity on the topic. So no matter whatever the type of questions they give, you'll be able to answer if you go through these sessions, because we are covering from the basics and we are not diverted from the topics. We are talking only with respect to the examination. Okay, examination point of view, be it IIT JAM, BT or GATB. Only the level that is required for that examination level, only that much you are talking. Okay. So today we are talking about what? Today we are talking about conditional probability and its properties. So when we talk about conditional probability, so that is the topics that we are going to cover today. So conditional probability, okay. One is conditional probability, its properties, and some examples and PYQs. So I think we'll be talking basics of conditional probability today. And next, when it comes to PYQs and all, we'll be doing it in the next session. Okay. So today, now we will be talking about conditional, what is conditional probability, what are its properties and all these things, along with some examples. Now, what is conditional probability? The word itself says there is some condition. The word itself says based on some condition. We are going to find probability based on some condition, based on some condition, based on some condition. We are going to find probability. Probability of what? Probability of an event. Going to find probability. That is the meaning of conditional probability. So what is this condition? What is this condition we are talking about? Let us see. Suppose they are telling if E and F are two events. If E and F are two events associated with the same sample space of a random experiment. Okay, of a random experiment. That means what? E and F are two events associated with the same sample space of a random experiment. Suppose a random experiment means it can be tossing a coin or tossing a dice. Okay. E and F, the events E and F should be associated with the same sample space. Same sample space means it should be associated with the same experiment. It should be associated with the same experiment. Okay. So it should be associated with the same experiment. Then the conditional probability of the event E. Then the conditional probability of the event E, given that Fs occurred already, is given by. Okay. Given that Fs already occurred is given by. So listen again very carefully. There are two events. There are two events. So listen carefully. There are two events. Okay. There are how many events? There are two events. So when we talk about conditional probability, there are two events. So that is event E and event F. So what is the probability of event E given that F has already occurred? That is the condition. That is what? That is the meaning of conditional probability. Let me open the document. See here. So when we talk about conditional probability, we are saying that what is the probability of event E given that F has already occurred? Okay. Now, suppose I give an example. Okay. Suppose in an over there are 6 balls in cricket game. Okay. Suppose the event F is that the first ball is already being hit for 4. What is the probability that the second ball will be hit for a 4? Okay. The first ball is already hit for a 4. That is event F. The event E is the second ball being hit for a 4. Okay. The first ball has already occurred. Okay. Like that. Here event F has already occurred. Okay. Event F has already occurred. Okay. Got it. Event F has already occurred. Event F has already occurred. That is, it has already happened. At that time, okay, at that time, how to find the probability of event E? That is given by, see here very careful. This formula is very important. P of E by F. That is probability of event E, given that probability of event F has already occurred. See, the conditional probability of event E, given that F has occurred already. Okay, that means probability of F is already given. That is, F has already occurred. So, what is the probability F? That is already given. So, what is the probability of E when probability of F has already occurred? When event F has already occurred. Okay, I'm repeating again and again. You have to find there are two events, event E and event F. Event F has already occurred. Then what is the probability of event E occurring? What is the probability of event E occurring given that event F has already occurred? That is the conditional probability. So whenever we talk about conditional probability, there should be two events. Okay, there should be two events minimum. At that time, one event has already occurred. With respect to that, what is the probability that another event will occur? Here we are talking about event E occurring and event f has already occurred. So that is given by whatever the event that has to occur, we are taking it on numerator. Whatever the event that has event that has to occur in future, that we are taking it as numerator. Event that has already occurred, we are always taking it in denominator. Okay, so that is given by, see here friends, probability of E intersection F divided by probability of F. Okay, probability of E intersection F divided by probability of F. So we know that this can be written as probability of E intersection F. That means what is common between E and F, intersection means. So this can be written as cardinality of E intersection F divided by cardinality of sample space divided by probability of F is what? Probability of cardinality of F divided by cardinality of sample space. So see here, both are of the same sample space. Both are of the same sample space. Same sample space. That is what the question is saying. Both are of the same sample space. That is the meaning of same sample space. Sample space, friends. Okay. Both are of the same sample space. So now what will happen? I can do what? I can cancel this. I can cancel this. So this will become equal to, this formula will become equal to n cardinality of E intersection F by cardinality of F. Okay. Provided that probability of F is not equal to 0. That event F, the probability of event F that has occurred should not be equal to 0. Okay, this is the formula. So probability of E with respect to F, that is probability of event E occurring with respect to event F that has occurred is given by, you can use either this formula or you can use either this formula. Okay, you can use this formula. This formula I have reduced it to this. Okay, you can use this formula or this formula. Okay, we use some other formula. So you can use either this formula, okay, or this formula, or this formula. Anything is fine. Both are, if you use also, you'll get same answer. Okay, this formula is reduced. This formula is reduced form of this formula. That's all. Got it, friends? So this is about conditional probability. Now, when it comes to conditional probability, to understand better, let us see some examples. Okay, this is the meaning of conditional probability. What is the probability of an event occurring such that another event has already occurred? That is the meaning of conditional probability. This is the meaning of condition. What is the condition I told? I was talking about some, based on some condition, we have to find the probability. Now you understood what is a condition. Okay, what is the condition that we are talking? You understood. Now they are telling a family has 2 children. Okay, example 1, a family has 2 children. What is the probability that both the children are boys? Then both the children are boys. Okay, here it should be question. Given that at least one of them is a boy. Okay, what is the probability that both the children are boys? That is, this is event E. Given that, when they say given that at least one of them is a boy, this is event F. Okay, this is for 100% sure they are telling at least one of them is a boy. Then what is the probability that both the children are boys? So in a family there are 2 children. Okay, in a family there are 2 children. They are saying what is the probability that both the children are boys? Okay, what is the probability that both the children are boys? Given that at least one of them is a boy. Out of 2 children, it is known that at least one of them is a boy. Okay, what is the probability that both are boys? That is the probability that they are asking. What is the probability that both are boys? That is event E. But they have already given that at least one of them is a boy. That is for surety. That is already the information that they have given. That is event F. That has occurred. That is at least one of them is a boy. So let us find out how to solve this question. So event F. So before that, in this question, we have to find out the sample space. Sample space is the same for both event F and event E. So your sample space is what? There are 2 children. 2 children, right? 2 children. 2 children. Yeah. Sample space is either both of them can be boys. First one can be boy, second one can be boy. First one can be boy, second one can be girl. Or first one can be girl, second one can be boy. And both can be girl. Okay. So here cardinality of S, that is number of sample spaces, cardinality of x is 1, 2, 3, 4. That is 4. Okay. Now, event E. Event E is about both children are boys. Both children are boys. Both children are boys means what I should write in the inside the set. What I should write both children are boys means I should write B and B. So this is B comma B. This is equal to what this implies? Cardinality of event E is nothing but what? Nothing but 1. Because here it is 1. Now event F. Event F is at least one of them is boy. At least one of them is a boy is given that at least one of them is a boy. Given that at least one of them is a boy means you have to take everything except G and Z. At least one of them is a boy means it can be one boy or two boys. One boy and another girl. Or first is a girl and second one is a boy. At least means one or more. So two children means one or more means one is a boy. At least one is a boy. Another one can be boy itself. One is a boy. Another one can be girl. First one is a girl. Another one can be boy. So here n of f is given by how much? 3 friends. N of f is given by how much? Is given by how much friends? Observe carefully. N of f is given by cardinality of f is given by 3. Now we have to find out probability of that both the children are boys given that at least one of them is a boy. That means we have to find probability of E with respect to f that is given by probability of E intersection f divided by probability of f. What is in the denominator? Same thing. Now, here we have to find E intersection f. E intersection f means what? That is what is common between E and f. What is common between E and f? See here, E and f, what is common? This is common and this is common. So here it is B and B. So here cardinality of E intersection f is what, friends? Cardinality of E intersection f is cardinality of E intersection f is what, friends? It is nothing but 1 is there, so it is 1 itself. Okay. So probability of E intersection of by probability of f is given by cardinality of E intersection of f divided by cardinality of s divided by cardinality of f divided by cardinality of sample space. So E intersection f is what? 1. Sample space is how much? Cardinality of s is 4 divided by cardinality of f is 3. Okay. And cardinality of s is 4. So this, if you see this and this will cancel, you will get 1 by 3. You will get 1 by 3. Okay. Here, friends, the answer is 1 by 3. So this one you can solve it in another way. Instead of writing all this, because in cardinality of s and cardinality of s will get cancelled. So you can directly write cardinality of E intersection f divided by cardinality of f. So this will be what cardinality of E intersection f is. Cardinality of E intersection f is what, friends? That is common between E and f. That is 1. 1 is common B and B. Then cardinality of f is 3. Same thing you will get. Okay, that is what I told you. So here I showed you, see here. I told you can use either this formula, okay, or this formula. So this you can say this first formula, this is second formula, but both are one and the same. Okay, both are one and the same. So carefully, friends. So here I have used this formula. See here. Here I used which formula? Here I used first formula. Here I use second formula, but same answer. Okay. With more practice, you can use second formula directly because this is more simple. Okay, but if you have feel difficulty in understanding, you can use first formula. It's not a problem. Okay. Now I hope at least some clarity would have got about solving questions on conditional probability. Let us look at another example. Look at this, friends. They are telling, observe carefully. They are telling 10 cards are numbered 1 to 10. They are telling 10 cards are numbered 1 to 10. Okay. Are placed in a box, mixed up thoroughly. Okay. 10 cards. This is a box. Okay, this is a box. Okay, there are 10 cards. Cards number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are mixed up thoroughly. They are thoroughly mixed up. Okay, and then one card is drawn randomly. One card is drawn randomly. Okay, so if 10 cards means, so n of s will be how much? Sample space is nothing but, okay, let me write the sample space. 10 cards numbered 1 to 10 means sample space will be nothing but 1, 2, 3. For your understanding, I'm writing, but in the examination, while solving, you will directly know it is 10. N of s is 10. You need to write all this. So n of 5, 6, 7, 8, 9, and 10. So this is s. So n of s is nothing but 10. Okay. Okay. This is what we got. If it is known that the number on the drawn card is more than 3. If it is known means what? That is, you already know the information. It has already occurred. It is known, if it is known that the number on the drawn card is more than 3. This means what? This is f. If it is known, given that, when they say that, this is a hint. What is f if you have to know? If it is known, or if they given the before a statement, then this is talking about which event? This is talking about event f. Event f. If they are asking what is probability of some event, then that is event e. You have to remember. Then what is the probability that it is an even number? I told what is the probability if they say this is event e. Okay, this is event e. So let us write down here. Event e is talking about getting even number. Getting even number. Okay, event e is talking about what, friends? Getting even number. Okay. Now talk about even number 1 to 10. What are the even numbers that we have? We have 2, 4, 6, 8, and 10. So here n of s will be what? N of s will be equal to 1, 2, 3, 4, 5. This will be equal to 5. Event f is talking about card is drawn is more than 3. Getting a number drawn on the card is more than 3. Getting a number more than 3. Getting a number more than 3, that is an even number. Okay, getting a number more than 3 means what are the numbers more than 3? It can be 4, 5, 6, okay, 8. Sorry, wait, just let me. Number more than 3. It is not talking about even number. It is talking about number more than 3 means 4, 5, 6, 7, 8, 9, and 10. So here what, friends? Here n of, it is not n of s, it should be n of e. Okay. It should be n of e. Small correction, this should be n of e. The n of s is what, friends? N of f will be equal to, actually we will not be using n of e. Okay, while solving the question. Anyways, just for your understanding, I'm writing. N of f will be equal to what? 1, 2, 3, 4, 5, 6, 7. Okay, this is equal to 7. 1, 2, 3, 4, 5, 6, 7. Okay, n of f will be equal to 7. Now we have to find out what the formula. We know that it will come V intersection f. V intersection f means getting a number more than 3, which is an even number. Okay, let me write it here. Getting a number more than 3 and is an even number. Getting a number more than 3 and is an even number. So that is equal to what, friends? For that I can write down what? It should be more than 3. Okay, it should be more than 3 and it should be even number. So that means what? That means what? What is common between these two? What is common between these two? So between these two, what is common? 4 is common. Okay, 6 is common. 8 is common. And 10 is common. Let me write down. What is common? You have to write down. 4, 6, 8, and 10. Okay. 4, 6, 8, and 10. 4, 6, 8, and 10 are common. So here, n of E intersection F will be equal to what? N of E intersection will be equal to 1, 2, 3, 4. 4 is the number. Cardinal of E intersection F is this one. So now we have to find out what? We have to find out simple. Now we have to find out what? Probability of E with respect to F. Probability of E with respect to F. Okay. Now everything is sorted. Now we have to find what? Probability of E, probability of E with respect to F. So for this, we can use this formula P of E interaction of by P of F. That is equal to, we can use this formula directly. N of E intersection F divided by N of F. N of E intersection F is what? N of E intersection F is 4. Okay. Here we need not use the sample space because we are using this formula. We are using this formula. Okay. As per this formula, N of E intersection F is 4 divided by N of cardinality of F is 7. So here the correct answer is 4 by 7. Okay, friends. Here the correct answer is 4 by 7. Got it, friends? This is how we solve this question. So how to solve this question? First, we have to find getting an even number, then now getting a number, not even number. F is talking about number more than 3. Getting an even number means up to 10 means starting from one even numbers are 2, 4, 6, 8. Next, getting a number more than 3 means 4, 5, 6, 7, 8, 9, 10. Then the intersection of getting a number more than 3, which is an even number. That is 4, 6, 8, 10. So N of E intersection F will be 4. So probability of E with respect to F is N of E intersection F divided by N of F. That is cardinality of E intersection F divided by cardinality of F. That is equal to what, friends? That is equal to 4 by 7. Okay, this is the answer. That questions will solve later, that PYQs. Excuse me. Now let us learn the properties of conditional probability. When it comes to properties of conditional probability, you have to remember that, see, just listen here carefully. Observe carefully here. You can look at the screen. If you look at the screen, what you're seeing, let E and F be events of a sample space S of an experiment. Okay. Sample space S of an experiment. Let E and F be two events of a sample space S, that is of an experiment. That means same experiment means same sample space. Same sample space means it will be S. So for that, probability of sample space S with respect to F is equal to probability of sample space F S with respect to E is equal to probability of F by F. F is what? The event that has already occurred. Event occurred is equal to 1. So whether this or this or this will always be equal to 1, the value of 1. So probability of S by F, probability of S by E, probability of F by F, probability of F with respect to F is 1. Because why? Probability of F will be some value, probability of divided by probability of F will be same value. It will cancel itself and you will get 1. So probability of S by F, probability of S by E, where event E has to occur and event F has already occurred, that is equal to probability of F by F, that is equal to 1. This is the first condition. Now they are telling another one thing you must remember, friends. Suppose probability of A, okay, event has occurred. Suppose event has occurred is 1 minus probability of A dash or A bar. This can also be written as A dash. That is what? This is event A occurring. Event A occurring. This is what? Event A not occurring. Suppose if they ask you to find P of A dash, if they ask you to find P of A dash, if they ask you to find P of A, event A not occurring, that time you have to write 1 minus P of A, event A occurring. Probability of event A not occurring is equal to 1 minus probability of event A occurring. This you have to remember, friends. So this you have to remember, friends. So probability of event A occurring is equal to 1 minus probability of event A not occurring, or you can also write probability of event A not occurring is equal to 1 minus probability of event A occurring. This you have to remember. Okay, this is one more property. Next, if A and B are two events of a sample space S and F is an event of S such that P of F is not equal to 0. Okay, so they're talking about conditional probability here. So here P of F is not equal to 0. The F is an event. that has already occurred. Okay, F is an event that has already occurred. So there are two events A and B such that P of A union B by F is equal to P of A by F, P of B by F minus P of A intersection B by F. So this is what? This is combination of nothing but this is combination of this formula is nothing but combination of addition theorem and conditional probability. Addition theorem and conditional probability. So look at the numerator. So look at the numerator here. P of A union B is nothing but equal to P of A plus P of B minus P of A intersection B. Okay, this is what? This is nothing but addition theorem. This is nothing but addition theorem. For everywhere they have divided by F. That's all. Divided by F. Divided by F. And divided by F. That's all. That is the formula. So for addition theorem, they were divided by F, and this is a combination of addition theorem and conditional probability. There is another event. So next is P of E not occurring with respect to F is equal to 1 minus P of E occurring by F. E is equal to not E. That is same as this. Okay, same as this. So P of A dash is equal to 1 minus P of A. So similarly, instead of A dash, you can also write A slash. Okay, P of E by F can also be written as 1 minus P of E not occurring with respect to F. Because I cannot talk about F not occurring because F has already occurred. P of E by F is equal to 1 minus P of E dash by 1 P of E dash by F. Or if I send this that side and send this side, I will get this one. P of E not occurring with respect to F is equal to 1 minus P occurring with respect to F. So here nothing but they have divided by F. Instead of A, they have replaced E, and everywhere they have divided by F. That's all. That is the meaning of this third property. Okay. Suppose I have P of E dash is equal to 1 minus P of E. You know that, right? P of E not occurring is equal to P of 1 minus P of E occurring. So for this, if I divide by F, this becomes conditional probability. Same thing is here. Okay. Next. If E and F are disjoint events, then P of E and F, P of E intersection F. Intersection means what? Intersection means what? Common is 0. That means what? Disjoint event means they're not related events. This you can also call it as mutually exclusive events. Mutually exclusive events. This you can also call what? Mutually exclusive events. Okay. This you can also call mutually exclusive events. We know that mutually exclusive events, that is E intersection F will be equal to a null set. E intersection F will be equal to null set. Null set means nothing is common. In intersection, nothing common. That time, mutually exclusive events or disjoint events, they are one and the same. They are not related. Nothing is common means probability of E intersection F will be equal to what? Will be equal to 0. And E and F are disjoint events or mutually exclusive events. Then probability of E intersection F. Suppose in question, suppose two events E and F are such that they are disjoint events. Find the probability of A given that F has already occurred. At that time, probability of E intersection F, when you have to find in the formula, that time you have to put the value of 0. That time you have to put the value of 0. When they say that E and F are disjoint events, it is understood that the probability of E intersection F is 0 because E intersection F is a null set. There is nothing common. That time, when nothing is common, probability of E intersection F will be equal to 0. This is very, very important point. Highly important property. Make a note of it. Highly important property. Okay, friends. So this is it about today. This morning session, that is, we discussed about conditional probability basics, and also we solved some examples based on conditional probability. Then we learned these 4 properties. So in the next class, in the upcoming class, we'll be solving PYQs based on conditional probability and its properties. Got it, friends? So I am once again reminding you. So rank assurance program with respect to IIT JAM, BT, and also CAT-B and Common University Entrance Test PG for 2025. It is going to start from 1st October. So enroll as soon as possible and get head start with respect to your preparation. So don't forget, again I'm telling, it is starting from 1st October, friends, and the fee is 22K. All right, friends. Thank you so much for attending the session. If you have any doubt or if you need any feedback, Please put it in the comment section. Please like the session and share with your friends. It might be useful. Okay. Useful to your friends also, those who are preparing for the examination. All right, friends. Thank you so much for attending the session. Take care. Until next time, until next session, I'll see you. Please take care. Please keep preparing well. All right, friends. Take care.